In this video, we're going to take a look at a term called the molar solubility, and we're going to take a look at how that relates to KSP as well. So molar solubility is the maximum that can and will dissolve. So if you have a compound and you put it in a certain amount of water, the maximum number of moles that will dissolve in that volume of water is called your molar solubility. And we typically express it as a molarity. We express it as a moles per liter. So we sometimes also call the molar solubility the molarity of solution. And the term and the variable for molar solubility, or the symbol for it, is the MSP, uppercase MSP, molar solubility. So let's take a look at an example here. Calculate the molar solubility for the following solutes fully dissolved in 5 times 10 to the power of 2 milliliters of water. So essentially what we're saying is if I have 500 mils of water, I can dissolve 5 grams of NaCl. And I'm telling you that that's the maximum that I could dissolve in that 500 mils of water. If that's the maximum that I can dissolve in that 500 mils of water, then that's the molar solubility that I'm asking you for. Essentially, I want you to tell me the molar solubility, not in grams per mil, but in moles per liter. Okay, in moles per liter. So you could say 5 grams in 500 mils is the solubility, but the molar solubility really is in moles per liter. So what we're really doing here is we are going to be calculating the concentration at this point. C is equal to N over V. And so we know our volume. Our volume is going to be 500 mils, and we'll deal with sig figs after, or 0.5 liters, right? Because you do divide by 1,000 to get to liters. We need our mole value. And so just as a reminder, to find the number of moles, we use our relationship mass is equal to moles times molar mass. Therefore, moles is equal to mass divided by molar mass. So our moles is going to be the mass of the ionic compound divided by its molar mass. And so the molar mass, you can calculate it using the periodic table. And if you don't remember to do that, you can go back and do some grade 11 review. So we have 22.99 for sodium plus 35.45 for chloride. And that gives us 58.44 grams per mole. And so we'll do 5 divided by that, and we'll get 0.085557837 moles. So now what you can do is you can plug all your numbers in. You have the number of moles, and you also have the volume. So we can say is equal to 0.0855. I have all my digits in the calculator, so I'm not going to rewrite every single one here. Don't round until the very end. So keep as many digits in your calculator as you can. And then divide it by 0.5 liters. And we get 0.171115674 moles per liter, or approximately to 2 sig figs, 0.17 moles per liter. So therefore, the MSP, if you can only dissolve 5 grams in 500 mils of water, that's the molar solubility, it's the maximum you can dissolve there, is going to be 0.17 moles per liter, approximately. We rounded to 2 sig figs because there were 2 sig figs here. So essentially, if we tell you that the maximum you can dissolve in a certain volume of water is, if we give you that, that's the maximum solubility. And we ask you to find the molar solubility, just find the concentration of that solution. And that's going to be your molar solubility. Because as you can probably predict, the idea is that we're going to try to use molar solubility in an ice table later on, since we use molarities in ice tables. So I'd like you to try number 2 over here. calculate the molar solubility using the same volume of water for lithium nitride. Um, Pause the video, try it, then unpause to check if you're on the right track. So remember, we're asking you for molar solubility. We can dissolve a maximum of 3.7 grams in 500 mils of water, but that's not the molar solubility. You want to represent this in moles per liter. So what we're going to do is we're going to try to find the concentration at this point. As we know, the volume is already given to us. So volume is equal to 500 mils or 0.5 liters. And we need to find the moles. As we saw before, the moles is equal to mass over molar mass, which is equal to 3.7 grams over the molar mass of lithium nitride. So we have, if you don't remember, you can go to your periodic table that we have in our calendar or wherever else your teacher has it located. So we can go to our periodic table. And you can take a look at the molar mass values, right? So lithium should have 6.94 once this opens up. Lithium is 6.94 and nitrogen is 14.01. So just in case you forgot where to find them, now you know. And you can also, like I said, do some grade 11 review. 6.94 times 3, because there's 3 lithiums, plus 14.01 because there's 1 nitrogen, gives you 34.83 grams per mole. Cancel out the grams and you're left with moles. So 3.7 divided by that 34.83, and we get 0.106230261 moles. I always like to double check just to make sure I didn't make a mistake with the molar mass. So 3 times 6.94 plus 14.01 gives me 34.83. That's good. Then 3.7 divided by that gives me 0.106230261 moles. And now we can plug everything in here again. And I'm not going to write every digit out again, but I keep it all in my calculator. So we have 0.106 moles divided by the 0.5 liters, and we get 0.212460522 moles per liter, or approximately to 2 sig figs, 0.21 moles per liter. So therefore, the molar solubility is equal to 0.21 moles per liter. And this is to 2 significant digits or significant figures. If you want, you could also just call molar solubility X when you're doing this work, but it's not that much work to write what the molar solubility actually is. So molar solubility, simply the concentration that we're looking for when you've dissolved the maximum in a certain volume of water. And that maximum will vary depending on what the temperature is. So on that note, that means that the KSP varies based on temperature, just like any other K expression that we're going to see later on. So what we're going to do is we're going to connect the molar solubility to the KSP. We're going to use our molar solubility MSP in order to find the KSP of different substances. And then we can also use the KSP to figure out the molar solubility, because the KSP is based off of the molar solubility when your solution is saturated. In other words, when your solution has the maximum amount that it can dissolve. No less, no more, just the maximum amount that it can dissolve, but that will be in the next video. For now, your skill should be to be able to calculate the molar solubility if you're given the information provided that you need.